Given that when x is 1, y is 4, solve the differential equation dy by dx is equal to y over x times 2x minus 1. Hence, find x when y is 12. Show what happens to y when x becomes large. So we've got to solve dy by dx is equal to y over x times 2x minus 1. If we now separate the variables, because this is the type of differential equation we've got, then we're going to take the y over here, that'll make it 1 over y, dy, and then take the dx up here, so we're going to get 1 over x times 2x minus 1 dx. And then if we integrate both sides, so if we integrate of 1 over y dy is equal to the integral of 1 over x times 2x minus 1 dx, we'll call that equation 1. Now, if we split the right-hand side into what's known as partial fractions, so we'll have to do a little side here, so we're going to do it in blue here, a different colour. 1 over x 2x minus 1 is equivalent to a over x plus b over 2x minus 1. And therefore, 1 over x 2x minus 1, if we make the same denominator x times 2x minus 1, that means this side a has to be multiplied by 2x minus 1 and b by x. So that means that 1 has to be equivalent, because the denominator is the same, we can now say that 1 has to be equivalent to a times 2x minus 1 plus bx. If we let x be equal to 0, that means b won't occur, so we put 0 in here, we're going to get minus 1 times a is 1. So that means that 1 is equal to minus a, so a is equal to minus 1. If we let x equal to a half, i.e. this bracket will be equal to 0, we're going to get that 1 is equal to a half b, therefore b is equal to 2. Right, putting that back into the this, I'm going to swap these two over because I've got minus 1 here. I just want the negative sign to come second. So I'm going to write 2 over 2x minus 1, that's b over 2x minus 1. And then a is minus, so going to be minus 1 over x. If we now substitute that back into the differential equation, so we've got integral 1 over y dy now will become the integral of 2 over 2x minus 1 minus 1 over x dx. Now, the differential of ln of x is 1 over x, therefore if you integrate 1 over x, you get ln of x. So this will be ln of y. This is type f dash of x, f of x, so that will become ln of 2x minus 1. If you differentiate back, you'd get 2 over 2x minus 1. And this will be minus ln of x. And we have to add in a constant of integration. Now, but we're told when x is equal to 1, y is 4. Substitute in. We've got ln of 4 is going to be equal to ln of 2 times 1 minus 1 minus ln of 1 plus c. So ln of 4 will be equal to, now 2 times 1 is 2, 2 minus 1 is ln of 1 minus ln of 1 plus c. Either these become equal to 0, or you say that ln of 1 is equal to 0. So therefore c must be equal to ln of 4. Put that now back into here. We get ln of y is equal to ln of 2x minus 1 minus ln of x plus ln of 4. We now use the rules of logarithms. So the rules we have are log a of x times y is log a plus log a of y, and then log a of x over y will be equal to log a of x minus log a of y. So dealing with these two, this will now become ln of 4 times that bracket using this rule here. And then we have to divide that by x using this rule here. Put in the brackets, obviously. Because we've got ln and ln on each side, we can now say that y is equal to 4 2x minus 1 over x. So this is our solution to our differential equation. Let's go back a minute. So this is our answer here to this one. Okay, so we got y is equal to 2x minus 1 over x. So when y is equal to 12, we're going to put 12 equal to this. We've got 4 times 4x minus 1 over x is equal to 12. If we multiply by x and divide by 4, we're going to get 2x minus 1 is equal to 3x. So 12 divided by 4 is 3, multiplied by x. Collecting the x's on one side, we're going to get that x is equal to minus 1. Now, what happens when x becomes large? So if we now do this, 4 times 2 is 8. So we're going to get 8x over x. And then minus 4 over x. So 4 times minus 1 will make minus 4 over x. The x's here will cancel out, so we get y is equal to 8 minus 4 over x. So as x becomes very large, 4 over x will approach 0, and you're going to be left with just y approaching 8. So y will approach 8. Therefore, y approaches 8 when x is large. Okay, this has been a video to show you how to solve a differential equation and then use the resulting equation to solve some problems. I hope you've understood, and I thank you very much for watching.